Alright, in this video I'm going to work through the review for test over chapters 8 and 9, and although I continue to call it chapters 8 and 9, there is that little bit at the beginning from 3.6, and I hope you have a copy of that review. I think in my math lab I call it the updated review, and it starts. Question number 1, it says to find the domain and the range of the given relation, and we have -1, -5, and 5, 0, and 8, 7, and 7, 8. I won't be copying down all the questions, but I needed to get this set of ordered pairs here. This is the relation. The domain will be the set of all x values, so it'll be -1, 5, 8, and 7. If an element is repeated in there, you only list it once in either the domain or the range. And then in the range, it is the y values, so it's -5, 0, 7, and 8. That is domain and range. Question number 2 gives us another relation. It has -6, 3, -3, -2, 5, -4, and 4, 1. And it wants to know if it is a function. And in order to test for a function when you have a relation, you see -6 is related to 3 and never related to anything else. -3 is related to -2 and never related to anything else. 5 is related to -4, and I don't see another 5. 4 is related to 1 and not anything else. So each x corresponds to one and only one y. So this is yes, it is a function. Number 3, I have the set -6, 5, -6, -7, and -6, -1. And this particular relation is not a function because there is a repetition of the -6 in the x position, and each time it is corresponding to a different y. So it is not uniquely associated to its y. Number 4, I'm going to draw, and my sketch is going to be rather messy, but we have kind of an oval. It may be an ellipse, and it wants us to use the vertical line test to see if this is a function. Now, you can use a vertical line if any vertical line intersects the graph in more than one spot. Then a vertical line is an x line. This might be the line x equals -2 or 3, and when x is, I'm going to say -3, then there is one y down here and one y up here, so that means that that x value has different y's, so this one fails, and no, it's not a function. It failed the vertical line test. All right, let's look at number 5. Numbers 5 and 6 are both about function notation. So number 5 says if we have the function h of x is 3x squared plus 4, and you want to find h of -4. Plug in -4 in the place of x, so 3 times -4 squared plus 4. Using order of operations, I'll square first, so it's 3 times 16 plus 4, multiply 48 plus 4, which is 52. H of -4 is 52. That's the first part. The next part asks you to find h of 0. So that will be 3 times 0 squared plus 4. That's 3 times 0 plus 4. that is 0 plus 4, which is 4. H of 0 is 4. Finally, it asks for h of 4, so that's 3 times positive 4 squared plus 4. That's 3 times, it's still 16 plus 4. That's 48 plus 4, which is 52. H of 4 is 52. So there are my 3 values that it asked me to do. Number 6, I'm really following the same process. This time it calls the function f of x is 2x minus 5. It wants to know f of negative 1, so I'll put negative 1 in the place of x. That's 2 times negative 1 minus 5. That's negative 2 minus 5, which is negative 7. F of negative 1 is negative 7. Then it says find f of 0. So that's 2 times 0 minus 5, which is 0 minus 5, negative 5. F of 0 is negative 5. And the final one, it asks about f of positive 1. So that's 2 times 1 minus 5, which is 2 minus 5, or negative 3. F of 1 is negative 3. All right, the next ones are graphs, and so since I'm just working on my notebook on my screen here, I'm going to be drawing a sketch. You would have a nice grid if you did it. It asks you to graph f of negative, it asks you to graph, push this, I'm trying to get to my eraser, there we go. All right. All right, number 7 says to graph f of x is negative 8x. Now remember that f of x is function notation for y equals negative 8x. You are welcome to make a t-chart, get some values. I'm going to do it with slope-intercept, which is y equals mx plus b. Since there is no b value sitting here, we hopefully understand that it is 0. So we will begin at 0 on the y-axis. And our slope is negative 8. It needs to be a ratio or a fraction, so I'll put it over 1. The numerator is the rise, tells me to go down 8. The denominator is the run, it tells me to go right 1. So now this is where I'm just going to have a pretty bad sketch. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, this is not going to be a very neat graph because I don't have a formal grid. All right, the b value is 0. That means that I will click a point there. If you're doing this in MyMathLab, you will have chosen the line tool, and it allows you to plot 2 points. That would be 1 point. Then I would follow my slope instructions, which say to go down 8, go right 1, and I would click my second point. I would not have to worry about drawing a nice line if I'm in my MathLab. Mine's not so good. There we go. But hopefully you get the idea. All right, number 8. It asks you to graph f of x is equal to negative 1/2 x. Now, even though on all the work that I have, I do this problem, I'm going to change it in the video to demonstrate something. What if it said negative 1/2 x plus 3? So I'm just making a change because I want to show you something. If I don't put a plus 3, then it's going to go through the origin like the last one did, and I just decided I'd like that to be a little different. All right, y is equal to, when I have a negative fraction, I like to attach, let's see if I can't get my eraser. There we go. I like to attach the negative sign with the numerator, and that's just my choice. So the b value is 3, and remember it's on the y-axis. The m is -1/2. So since I put the negative with the numerator, I'm allowed to say that means down and right. If it's just sitting out in front like it is in the original problem, you have to either put it with the top or put it with the bottom. Don't put it with both, because that would have negative over negative, which would mean positive. All right, here is going to be my rather sloppy graph, but hopefully it gets the point across. All right, I will begin at 3, and it's very important that you remember it is a y-intercept. From that point, whoops, let me put that down. From that point, I will go down 1, right 2. Down 1, right 2. There we go. In my math lab, a line will, that is not drawn well at all. All right, down 1 and right 2 should be there. I think I went down 2 and right 2. All right, down 1, right 2 should be there. This is by no means an accurate graph, but you did see me graph the y-intercept and the slope. And remember, I changed the problem from what was on the worksheet. I put a plus 3 just so we would do something different. All right, let's see what's next. All right, now we're going to have some problems. We're going to find the equation of lines, and every one of them, we're going to get them in the form y equals mx plus b, or as the book or my math lab will say, f of x equals mx plus b, and you will just type this part in. So number 9, I've got my tools available if I need them, all my formulas, and it says the slope is 9, and it goes through the point 3, 2. Because I'm given slope and a point, I use the point slope form, or point slope equation, which is y minus y1 is equal to m times x minus x1. So that's y minus 2 is equal to 9 times x minus 3. Use the distributive property. I'll have y minus 2 is equal to 9x minus 27. Add 2, and y is equal to 9x minus 25. And I'm done. That's my equation. My math lab allows you just to type the right side in because it already has f of x equals. I'm using y, but it says f of x. All right, number 10. Find the equation of the line passing through the given points. So I am given the point 417. I'm also given the point 522. I have to do this in 2 steps. Step 1, I'm going to find m. The slope formula is y1 minus y2 over x1 minus x2, although you might have used it with y2 minus y1 and x2 minus x1, it does not matter. The y's are getting subtracted on the top, the x's are getting subtracted on the bottom. So I've got 17 minus 22 over 4 minus 5. So the way I did it, I've got negative 5 over negative 1, which is 5. If you have these reversed, because that's what you're used to doing, you will get positive 5 over positive 1. You'll still get 5. Part 2, now I'm going to use point slope. So I have y minus y1 equals m times x minus x1. You get to pick which of these 2 points you want to be the y1 and the x1, and I'm going to pick, and it doesn't matter, 417, and remember we just calculated that m is 5. So it's y minus 17 is equal to 5 times x minus 4. That's y minus 17 is equal to 5x minus 20. I just use the distributive property. I add 17 to both sides, and I get y is equal to 5x minus a 3. And that's what I will type in. That's the equation of my line. Let's look at number 11. Remember, you can pause this video anytime you want if you feel like my pace is too fast. Number 11, find the equation of the line, and my line goes through, here comes a point, 8, negative 9, and it is perpendicular to, and that's the symbol for perpendicular, 6y equals x minus 12. Well, the reason we're given this perpendicular line is so that if I find the slope of this line, I'll know what the slope of my line is because of this relationship of perpendicular. All right, I can't get the slope of this line until I get it in slope-intercept form. Y is equal to, there's an unwritten 1 there, so I'm going to grab the coefficient to be 1/6 x minus 2. The slope of this perpendicular line is 1/6. The slope of my line is therefore negative 6. How do I know that? Perpendicular, and abbreviate it, means opposite in sign and reciprocal. So I flip it over to be 6 over 1 and I change its sign to negative 6. So now I can use point slope because I was given a point and I found the slope. Y minus y1 is equal to m times x minus x1. Y minus negative 9 is equal to, let's see, I got a slope of negative 6 times x minus 8. I would say that one of the most common places for an error is right here. The formula has a minus sign and the y value had a negative, so it's minus minus. And I really didn't need that parentheses. I'm not quite sure why I had it. So I have y plus 9 is equal to distributive property, negative 6x plus 48. Subtract 9 from both sides. And I get y is equal to negative 6x plus 39. So it was important to recognize what it means to be perpendicular. It means if you know the slope of this line, you take its opposite reciprocal, and that's the slope of your line. Number 12. Find the equation of the line through, here comes a point, 3, 6, parallel to, and I'm using the symbol for parallel, y equals 3x minus 5. Well, if two lines are parallel, they have the same slope. The slope of the given line is 3. That means that the slope of my line is 3. Parallel, same slope. So once again, I'll use the y minus y1 is equal to m times x minus x1. So I have y minus 6, I'm up here getting my point, is equal to 3 times x minus 3. Y minus 6 is equal to 3 times x is 3x, 3 times negative 3 is negative 9. Add 6, and y is equal to 3x minus 3. All right, the next few questions on the review and in my math lab are going to be multiple choice, but I'm not going to do them as multiple choice. Number 13, it says to graph f of x is equal to x squared plus 2. So, like I said, I'm not going to use multiple choice. I'm just going to talk about what I should be looking for. When I see this, I know that it is a squaring function. I know the shape of the squaring function, which is kind of U-shaped. It's really a parabola. It's not quite a U, but it sort of looks like it. Then I look at the transformation, and this says plus 2 on the outside, so it will go up 2 units. So here's what my graph should look like when I find it. I think about the parent function, the U shape, and it looks like this. And this won't, if I were graphing, I wouldn't graph this, but I would think it. And then my graph is supposed to be identical in shape, but shifted up 2 units, so it will look like this. So I would look for the choice that looked like the U, whose bottommost point was at 2. The next one, still multiple choice on the review. It says h of x is equal to absolute value x plus a 3. All right, let's talk through it. It is an absolute value graph. Its shape is V-shaped, and the transformation, because it's on the outside and it's positive, it's going to go up 3 units. So my sketch, I know that the parent function would look like this. My function will be shifted up 3 units, so mine will look like this. So I would be looking for a multiple choice one that was like that. Number 15, which is the last of these, it says to graph f of x equals the square root of x plus 7. All right, this is a square root function. The shape of the square root, I call it the branch. And because they are working inside the square root, it's going to have a left-right shift, opposite of what the sign says, so it's going to go left 7. So I think first about the shape. It looks kind of like that. So I go 1, 2, 3, 4, 5, 6, 7. And I would actually be looking for the graph that looks somewhat like that. All right, I have gone and gotten some grids because these next few problems really are going to look much better if I have grids. So number 16, it asks me to graph x plus y is less than or equal to -4. Now, you've got to get the boundary line graphed, and I always like to solve my inequality for y. So I'll subtract x from both sides, and I get y is less than or equal to -x minus a 4. Right now, I encourage you to stop, take a look at the inequality symbol, and make a mental or physical notation that it is going to be a solid line because there's equal with it. If there's no equal, it'll be dotted. And that you will shade below because it says y is less than. The m value is -1, and that's going to be over 1. The b value is -4. So I will begin at -4, and then I will go down 1, right 1. So I'll try to graph in red. So here's -4. From there I will go down 1, right 1. Now, because I'm doing this on a screen, it is very difficult for me to get a straight line, but I'm going to give it a try. All right, this is supposed to continue. All right, it said solid line. I drew that as a solid line, and it says shade below. So I will pick one of my highlighters, and I will shade below. In MyMathLab, you will be picking your bucket. You will have a bucket, and it's got paint in it, and you will click it anywhere on this side so that you will pour the shading on this side. Okay, so I'm actually going to put my bucket with paint right here. That's what you will do. What this means is that any point on this side of the plane, along with the points on the line, make the original problem true. That was 16. Number 17. I am supposed to graph 2x plus 5y is greater than 10. Once again, I prefer slope-intercept. So I'm going to subtract 2x. I have 5y is greater than -2x plus 10. I'm going to divide everything by 5. And I have y is not equal to. Y is greater than -2/5 x plus, and that is 2. So immediately I look at this symbol and I know that it says a dotted line because it's not equal, it's not part of the solution, and it says greater than, so I will shade above. All right, my b value, I will start at 2. My m value is -2/5, which means down to right 5. So I'll graph this in red. Begin at 2. From there, go down 2, go right 5. And I'm going to do my best to get a straight but dotted line. Nothing perfect. Now, above it is on this side. So I would click my bucket on this side, and it will cause it to be shaded over here. But in MyMathLab, it's a matter of clicking the bucket tool and clicking it on the correct side of the graph. Mine said above, so I went above the line. All right, let's see where my next grid is. There it is. It's far away. Oh. All right, this is problem number 18. It asks me to graph x is less than or equal to -4. Well, when I have a line that does not have a y and it only has an x, hopefully you remember that you have a vertical line. Looking at the symbol, it is going to be a solid line. Now, when my line is vertical, I can only shade left or right. To the left is less, to the right is greater. So I will shade left. So I go to x is -4, and I pick any other point as my second point. Now I just went up and picked that one. You could have gone down here and picked one of these, but MyMathLab only allows 2 points. So I have this solid line. I'm sorry, that was not even a little bit straight. It's very slanted. There, that's a little better. I will go to my bucket tool, and to the left is where it's less. So I would pour my bucket on this side, and that means that it will shade over here. Okay. Let's look at 19. I hope I have a grid somewhere for it. Yes. Let me see if I have enough. Yeah. All right, I have enough grids. Whoa. And I hope you're not getting dizzy while I'm doing this. All right. This is number 19, and it is about systems of inequalities. Let me make this, stretch the screen out like it's supposed to be. I'm supposed to graph y is greater than or equal to x plus 3, and I'm supposed to graph y is greater than or equal to 4 minus x. All right, I'm going to take them and analyze them separately. For the first one, taking a look at the symbol, it says it will be solid. And I will shade, because it says greater than, I will shade above. The b value is 3, and the slope value, there's nothing there, so I know it's an implied 1. It's up 1 and right 1. So if I want to, I can go ahead and graph that line. B value is 3. From there, go up 1, right 1. In MyMathLab, and this is solid. By the way, when I talk about solid and dotted, there's a tool that allows you to pick a solid line versus a dotted line. And you'll just pick the one that's appropriate for your problem. All right, so let's see, I'm not going to grab my straight edge. I'm just going to do this the best I can. All right, I'm not going to shade yet. Hold off on the shading. All right, and then now on a piece of paper, I go ahead and shade. And I would have shaded above. So in my head, I'm thinking that this is the side I will shade. But you don't get to do that in MyMathLab, so I'm not going to do it. With the second one, I don't like this format, so I'm going to switch it to y is greater than or equal to negative x and plus 4. That way it's in slope-intercept form. It is also solid above. The b value is 4. The m value is an implied negative 1, so I'll put it over 1, so it's down 1, right 1. So if I graph that one, I begin at 4. I go down 1, right 1. And let me see if I can, didn't do very well, but it gets the point across. And I'm supposed to shade above it. So what I'm going to notice is that this one says above and this one says above. Now I have 4 regions. I have region 1, region 2, region 3, and region 4. I need to shade the region that is above both of the lines. So the only region that is above both of them is what I've numbered to be region 1. So I would take my bucket and pour it right here in this part, and I will get a graph that looks like this. If you look at my work, you'll see that I actually shaded above over here blue, and above over here yellow, and got a green intersection. But MATLAB does not allow you to do that. It expects you to figure out which of the 4 regions formed by intersecting lines meets both of the characteristics. All right, let's look at the last of the graphing. Let me find my next grid. It's here somewhere. Let me move it up. Oops, just grab the other one. There we go. All right, make it a little bit bigger. All right, this is the last of the graphing. This review is much longer than the actual test will be. All right, so I have y plus 5x is greater than or equal to 0, and I have 3x minus 2y is less than or equal to 6. Slope-intercept. Going to subtract 5x, y is greater than or equal to negative 5x. This symbol tells me it's going to be solid, and because it's a greater than, I will shade above. And let's see, the b value is an implied plus 0. The slope is negative 5. I'll put that over 1, so it's down 5, right 1. So if I graph that, there's my 0. It doesn't want me to do that. All right, there's my 0. From there I go down 5, right 1. I will have a line there. Let me see if I can, okay, pretend that was, oh, that's really bad, but okay, it'll be perfect in my MATLAB. Mine's a mess. Second equation, I'm going to subtract 3x, and I have negative 2y is less than or equal to negative 3x plus 6. Divide everything by negative 2, by negative 2, by negative 2. I have y. Well, stop. Because I divided by a negative, my inequality symbol reverses. It has to reverse. And then negative 3 over negative 2 is positive 3/2 x minus 3. There are so many places you had to be careful in this process. So the b value is negative 3. The slope value is 3 over 2, which is up 3, right 2. My inequality symbol told me also that it was solid and above. So, graphing that one, I have negative 3. From there, I go up 3 and over 2, and really messy, but slightly straighter line. Now, in this, I look and I see I'm supposed to be above that one and above that one. I have 1, 2, 3, 4 regions. I need the region that is above both of the lines, and it is here, so I would tip my bucket right here, and this side would be the point, the side of intersection. In the work, if you look at my just solutions, you will see a green region there. All right, the last few problems are about absolute values. We've got absolute value equations and absolute value inequalities. These come from the 9293 group. So number 21, we're going to solve, and it is an equation. I'll review the ideas. We have absolute value of 8n plus 4, close absolute value, plus 3 is equal to 1. All right, before I can do anything with this, I need the absolute value isolated. So that's 8n plus 4 isolated, I will have subtracted 3, and that gives me 8, absolute value 8n plus 4 is equal to negative 2. And in this particular problem, I will stop, because I hope you remember that an absolute value cannot equal a negative quantity. So I hope I have one I can do in a minute, but this one I had to stop. The answer is that there is no solution. Sometimes they say the solution set is empty, and the symbol for empty set looks like that. All right, number 22. I have the absolute value of 9n plus 5. Now, I had to manually change this question because it was too much like the last one. I changed what had originally been a plus sign to a minus. 20 is equal to 8 because I wanted this one to work out a little differently. Isolate the absolute value by adding 20 to both sides. I get absolute value 9n plus 5, close absolute value, is equal to 28. When an absolute value of an expression is equal to a constant, then you know that the inside of the absolute value, the 9n plus 5, is either a negative 28 or the 9n plus 5 is equal to a positive 28. Because if you take the absolute value of this, if it's negative 28, it checks. If you take the absolute value of positive 28, it checks. So subtract 5, you get 9n is equal to negative 33. Divide by 9, and I get n is equal to negative 33 over 9, and I think on my work I neglected to reduce that, but you need to. N is equal to negative 11 over 3, and I'm pretty sure I neglected to reduce it. The other side, I subtract 5 and subtract 5. I get 9n is equal to 23, and divide by 9, and n is equal to 23/9, and that can't be reduced. So if I'm going to try to get my work corrected, but if not, make sure that you reduce. All right, in these, it wants to know the solution set. So the solution set, the author will have this symbol, and you will put in a negative 11 over 3, comma, 23 over 9, and you don't have to actually put those set symbols, they will be there. So what I wanted you to notice from this is if the absolute value equation is equal to a negative, you stop, and the answer is the empty set. That will simply be a multiple choice. If you isolate the absolute value and it's equal to a positive quantity, you're going to have two answers. And now let's see what number 23 gives us. It asks us to solve absolute value of 13x minus 4, close, is equal to 0. So since it's equal to 0, in that case I only have one answer. So 13x minus 4 is equal to 0. Add 4. 13x is equal to 4. Divide by 13. X is equal to 4/13. Your solution set will have that single value. So if it's equal to 0 when it's isolated, you get one answer. If it's equal to a positive when it's isolated, you get two answers. If it's equal to a negative when it's isolated, you get no solution, or an empty set. All right, last two questions have to do with inequalities, less than or greater than, and this is problem 24. It wants me to solve and graph absolute value, x minus 8, close absolute value, minus 8 is less than or equal to negative 1. Isolate the absolute value. Add 8 to both sides. I have absolute value, x minus 8, close absolute value, less than or equal to 7. Now, two things to notice. First of all, we got it isolated. It's a less than. When it is a less than, I know this one is a less than or equal to, but it's still in the less than family, you're going to write an inequality that is between the negative and the positive of the constant. So negative 7 less than or equal to x minus 8 less than or equal to positive 7. So here's the negative, here's the positive. I think when I teach this, I talk about looking at it as a three-part inequality. You want x by itself. So you're going to add 8 over here, add 8 over here. That gives me 1 less than or equal to x less than or equal to 15. It is between those. On as far as an interval, blank comma blank, it is from 1 to 15. Because it has equal to, I will use the square bracket, which is to the right of the P. On a number line, and this part would be multiple choice in my math lab, you find the graph that has the interval between 1 and 15 marked, and that it has the square brackets. Okay? So you will answer with this and choose this. Last problem. Number 25, I'm supposed to solve in graph. I have the absolute value of x plus 2, close absolute value, greater than or equal to 13. It's isolated. I take a look at the symbol. It says greater than. When it says greater than, I'm going to take what's inside here and I'm going to say less than the negative of the constant, greater than the positive. It is not the between, it is the extremes. So I will say x plus 2 is less than or equal to negative 13, or x plus 2 is greater than or equal to positive 13. Solve each one of these. So subtract 2, x is less than or equal to negative 15, or subtract 2, x is greater than or equal to 11. So I like to think about the number line. It really helps me with the intervals. So negative 15, positive 11, x is either less than that or it's greater than that. It's the extremes. Both of these have equal to, so those are going to be the square brackets. I have to remember, because MathLab won't have it, that there's negative infinity out here, far left. There's positive infinity out here. This gives me an interval, union, an interval. First interval is from negative infinity to negative 15. Infinities always get parentheses. The negative 15 gets a bracket. The next interval is 11 to positive infinity. Bracket, because it had equal, always parentheses. That means if you get an x value anywhere here, it makes this true. If you get an x value anywhere here, it makes this true. Okay, hope that helps with the review. The test will be significantly shorter, but similar in the types of problems.